Welcome one and all to the 6th episode of D&D. Last time I incorrectly called it the 4th, it was the 5th, so this time it's the 6th. This time around it's only me. Zoe and I have streamed the episode on Twitch, but I mistakenly forgot to hit the record button, and this time around we've done a little bit too much progress, and I just don't feel comfortable having to redo this because it's my fault again. So hopefully next time I won't make the same mistake, but now I'm gonna pay for my mistake and actually redo the video. I'm gonna try to be as clear as possible, but I will not be typing that much. I will be simply going through code that we have done. You're gonna see some things that are a little bit different. I'm gonna try and explain them as I go along. So first of all, you can see here that quite a few things have changed on the scene. The top bit is all gone. The daddy character is gone. We don't need it anymore. And we've added a little character because we started working on enemies a little bit. Nothing much, but it's there. The first step of the day was to fix the character slidiness. And to do that, what you should have, that's called player controller. We now call it the character controller. But if we go to fixed update, that's where the big stuff is happening. So here in grounded, you can ignore this line for now, the first one, but you can focus on this one. So we simplified everything we had to simply apply the velocity based on the input, nothing else. And if instead we have no input whatsoever, right? By the way, this one also is a little bit different. You see it says game manager.script controller dead zone as opposed to just controller dead zone. That's because we have created a singleton called game manager where we centralize the controller dead zone. I might as well show you this right now. See, the public float controller dead zone is contained inside the game manager script. And the game manager script has a public static variable called script, which gets initialized in awake. Okay, so that way everybody else knows the controller dead zone is 0.2. That's really it. So let's go back to here. RB velocity is the player movement input. Okay, you can see also it says player dot. Why? Because we have a player script which controls the character controller. That way we'll be able to use the character controller for everything, including enemies. So enemies will be able to use the character controller. We should probably call it the character motor. We will do this next time, almost certainly, okay? But it's connected to a player. And this one is going to be called the controller instead of player. But anyway, let's continue. So speed, blah, blah, blah. Now here, if there is no movement whatsoever, then we check the velocity. So we check that we have any velocity in the first place, and then we check the sign of the velocity. Supposing it's positive, we're going to the right. If there is no obstacle on the right, we add a force to slow us down. So we're using the vector3.right shortcut simply because we're lazy, so it gets a 100, multiplying it by the stop speed, multiplying it by the negative of our current velocity, which as the velocity diminishes, obviously, we're gonna slow down less and less and less. So we should get a sort of like slowdown effect, which we can tweak by playing around with the stop speed. And then the same is done if there's no obstacle on the left, so we slow down. And then at the end, an important thing that we had removed last time, stupidly, is that we reset the velocity on the Y and on the Z to 0, so we don't get little sinking into the ground effect. That one's gone. All right, so that's already a good spot, and it should get us a character that doesn't slide, which you can see in this demonstration. See, the character is slowing down fairly fast, right? It's not super immediate, and in fact, for some precision movements, it's a little bit annoying, right? And we fall off, but we'll figure that out later. Now, another thing that we had in the previous episode was that these raycasts could like stop us. But now you'll see that our character sort of sticks. I've just noticed that it's a little bit silly almost, but it's fine because it almost never happens that you simply do this. But now the character will sort of go like, wall, mine, from anywhere. This may very well be a bug, we'll decide. But at any rate, you'll see how the character sort of stuck into it very sort of immediately, right? And this is because of a change that we've done that's fairly important. So let's go take a look at the change that we've done. So before, our check grounded used to have a transformed position change here. Okay, I am opposed to that because the checks should be checks and not actors. They shouldn't do things, not directly. Okay, so I've moved the transform change right here when we're grounded. So when we're grounded, we're changing to the ground point. Obviously, the ground point was private to this particular method or function, so we had to put it outside. So we put it right here. We created a new variable just for it, ground point y. And we did the same for up, and we did the same for the sides. And all of this is done just so we can force the position to be attached to whatever surface we have decided. Now obviously for up and for down it works a little bit differently, but in terms of ray casting it works exactly the same. So here you have the ground point y being ground hits I, for the up you have ground up point y, up hits y, same thing. And then for the sides, all right, you both points get annulled to 0 first, and then they get applied based on ij point x, same thing. So now we have all of these points that we can use, right? The problem is that for when we are above, that would be the point in which we hit the thing, right? We need to check the ceiling as opposed to the ground. And we've already checked the ceiling, so that's fine. The problem is that if we simply put you at up point, right, it's not going to work because your characters, or at least our character's pivot is down here. That means that if we hit the wall up here, we're going to end up here. Let me give you a better example where we're close to the actual ceiling, right here. Okay, if we hit it here with the head, this is the point, so it's going to put us here. So we need to subtract by something, which is the height of our player, and that will put us right here. And in fact, you'll see up point y minus player size y. So if we hit something in the head, it's going to teleport us right there. And now let's look at the sides. The sides are fairly similar, same principle. That transform is being down here at the end when the final velocity is being massaged, right? And we would be like here, for example. Again, the hit is over here, the pivot point is over here. So we would end up here. So we're subtracting, if we find something on the right, by half of our size on the x. And if we find something on the left, like here, we are adding half of our size to the right, like that. Okay, and let's see them right here. So this is obstacle found on the left, add player size divided by 2. Obstacle is found on our right, remove player size divided by 2. Okay, so that should do for all of these things. And that was the bulk of the class. What we did then is we decided to create a few more scripts just to try and create enemies. And we created a game manager. The player controller changed to the character controller. It changed, by the way, again to character motor. And the player. One thing that we also did is make absolutely sure that the character controller had updated defaults. So we took all of the defaults that were here, right, these, and we stored them on the other side. That's important to us. Correct? I don't know why I said correct. Understood? I don't know why I said understood. I'm on a video. Nobody can really respond. Sorry. Anyway, so all of these defaults are now kept here. We've also added a setup boolean and a player variable for the player. So the player is going to contain all of the information about input and only that. Therefore, the entire update function has migrated from the character controller over here. We've moved it to the player over here. Okay? And a player component has been added to the player object right here. And you'll see it's fairly simple. This one, it simply has update, and so it can control all of that. In order to make jump work, we had to make it public in the character controller. We had to obtain the character controller at start, and we had to set it up. We have then changed the start function to a setup function, which is a request of the player. So we can store the player and tell everything that it's set up. And then we use the setup boolean to tell fixed update to do things. So if we're not set up, fixed update doesn't even work. If we're not set up, nothing happens. Okay, but fortunately we get set up right away. Then in the game manager, we've put the various the layer masks, because it makes sense to have these centralized. Everybody has the same floor, everybody has the same enemy or the same player or whatever, and the death zone, and that's it. And so now we find ourselves with a player being able to control the variable movement input. There's another one in the character controller. It should be right at the top. No, it isn't, rather. The character controller simply uses this one. Let's see. That's right, player movement input, right? So it goes to the player that we've received through setup. And it obtains this information. And everything works exactly the same as before. Now, the last thing that we've added is we just quickly experimented with some enemies. So in order to decide how we interact with enemies, we need to check grounded, check the sides, check up, and so on and so forth. And we need to decide whether we've stomped an enemy, therefore killed it, or whether the enemy has touched us from the side, therefore it has killed us. And basically we're doing another raycast for the enemy mask as opposed to the floor mask, which gives us all of this information. And what you'll see we have achieved at this point is that there is an enemy over there. We can jump on it and kill it like this, okay? So it's not brilliant, obviously, right now. And the other thing that we can do is we can also hit it ourselves like this, and then we both die. The reason why we both die is we see each other as enemies. We're not necessarily going to keep that. We're going to make the enemy win, but the point is it kind of works, right? And that's basically it. So we find ourselves with a fairly robust movement system where we can slam into things, we can safely ram walls, etc. We can, slide off, etc. And all of these collisions, every single one of these collisions, are performed using raycasting. So there's absolutely no colliders at play here. Essentially, the only physics we've got is the forces we apply in the air and gravity consistently applying itself. That's it. So it's quite neat like that. Let's see. Boom. Right. So nothing really happened. Yeah, I don't know about this whole jumping up. We may change this a little bit because it does feel a little bit weird. Yeah, here we go. So thanks very much for watching. I'm sorry the video is much shorter and much more... makes a few more assumptions. I apologize, but yeah, I'm a little tired and clearly I made a silly mistake. If you have questions about what to do, just let me know and I'll make sure to answer them in the comments. Thanks again, and we will see you again next time, where hopefully I will not forget to hit the record button. Bye bye.